Hello, Sanjay. Sanjay, are you there?
Yes.
Sanjay, yesterday did you leave the meeting early? Because you didn't leave, you were there, but I was calling you and you didn't respond. So what happened?
No, ma'am. Actually I was having some issues, ma'am. So I texted you in the chat box.
You messaged me in the chat box?
Yes, ma'am.
Okay, I didn't check the chat box. Now you have come, nobody else. Who else? Okay.
Good evening, ma'am.
Good evening. How are you?
Fine, ma'am.
So all of you who are present, don't give me the answer loudly, just find the answer to the 3 questions that I have written here. Okay, now many have come. So now, which of the following compounds will react with sodium hydroxide solution in water? Now, what is the answer? Sai Kalyan, what is the answer?
I'm 2 minutes, ma'am. I'm doing.
Okay, okay. Ashwin, are you there? Ashwin?
Yes, ma'am. Yes, ma'am.
Can you switch on the camera? I want to talk to you. Hi, Ashwin. Now, you know, you have missed 2 classes of alcohols. What happened? You cannot miss classes like this.
I was not feeling well, ma'am.
These classes are, Ashwin, these classes are online, right? You can just switch on you don't have to do anything. You just have to hear it. Now, if you miss a class, how will you manage? Now, will you get to see the recording of the class?
Yes, ma'am.
Yeah, so Ashwin, you have to be more responsible. You have to take the responsibility of doing well in the exam. And for that, you have to be regular, Ashwin. You can't assume, you can't miss classes like this. It is very, very important. Do you understand this?
Yes, ma'am.
Okay, now you must see the recording before both, all the recordings you should see. Right, today's questions, these questions you can't answer because you have not attended the class, right? So today onwards, please attend the classes regularly. If you miss, then when you attend the class, before attending a class, you should have completed seeing all the recordings. Did you understand? Now, what are you learning in school?
Some solutions.
You are still doing solutions. Okay, so learn solutions well in the school also. Okay. Vaishnavi, can you give me the answer of the first question? Vaishnavi?
Ma'am,
Hmm.
ma'am, isn't the third one?
Now here the question, see now here first you see all of them. What is the first one? First one is a phenol, right? What is the second one? Second one is a aromatic alcohol, right? Third one is a tertiary alcohol. And the fourth one is a primary alcohol, right? Now
Ma'am, the
you
first
should,
one.
huh?
First one.
First one, only the first one. So phenols are more acidic than aromatic alcohols. Primary alcohols are more acidic than tertiary alcohols, right? So the most acidic is phenol. Now, who will tell me the next one? Phenol is less acidic than, less acidic than. Now, Sai Kalyan, are you ready?
Miss, you said option 2, miss.
It is the option 2. Very good. Orthonitrophenol. Why? Because you see, phenol comes in between, and nitrophenols are more acidic than phenols because of the nitro group. And methylphenol and methoxyphenol, they are all less acidic than phenol. So the answer is nitrophenol, because the nitro group is an electron withdrawing group, and electron withdrawing groups, they are they make phenol more acidic. Which of the following is most acidic? Benzyl alcohol, cyclohexanol, phenol, and metachlorophenol. Metachlorophenol. Which one is most acidic? Who will tell me? Now, chloro group, Cl is also electron withdrawing group. That's the only hint I can give you. Cl is EWG, electron
Ma'am,
withdrawing group. Yes, Hariharan, tell me.
is it option 4, ma'am?
It is option 4. Very good. It is option 4.
Due to chlorine being a electron withdrawing
Electron
group.
withdrawing. Yes, very good. Excellent. Now there is this question. Mark the correct order of decreasing or acid strength of the following compounds. Decreasing acid strength. All right. So how will I decide? Which will be the most acidic? Let us find out.
Nitrophenol, ma'am.
Nitrophenol. This
D,
one is
ma'am.
the
D,
most,
ma'am.
B is the most acidic. So the answer has to be 2, because only in B is the first choice in only one. So it makes it very easy. Then after B, just for understanding, after B is D, because here also nitro, but it is in meta position. So it is also more acidic than phenol, but less acidic than para-nitrophenol. Then the next one is A. A is phenol itself. And then after phenol is C. C is methoxyphenol. And the least acidic is, this is meta-methoxy, and the least acidic is orthomethoxyphenol. Okay, so para-methoxy, and this is meta-methoxyphenol. So now I hope you have understood to compare the acidic nature. So what are the important points that we learned for acidic nature? The most important points that we learned, they are the that I will summarize here. That alcohols are less acidic than phenols. Okay, so that is one. Alcohols are less acidic than phenols. Among alcohols, primary alcohols are more acidic than secondary alcohols, which are more acidic than tertiary. So this is the acidic nature of phenol. So primary are more acidic than secondary, and secondary are more acidic than tertiary. This is due to plus I effect, right? And then nitrophenols are more acidic than cresols, I should say, cresols, right? Nitrophenols are more acidic than cresols. Cresols because NO2 is electron withdrawing group, and CH3 and OCH3, they are electron pumping groups. Electron pumping groups make it less acidic, and electron withdrawing groups, they make phenol more acidic. Okay, so these are the things which will help you to answer questions in MCQs. These questions are very, very common. Now here there is one more observation that you would have made. See, like in this case, you have B and D. B and D both are nitrophenols. Only difference is that in B, the NO2 is in para position, and in D, the nitro group is in meta position. So whenever any substituent is present on ortho and para position, then it is more effective than when it is present on meta position, always. So the effect of nitro group will be more when it is the effect of this nitro group here. It will be more. Why? Because it is on para position. Here the effect of nitro group will be less. Why? Because it is on meta position. So if ask you to compare in such a way, remember substituents present on ortho and para position are more effective. Whatever effect they have, they will have greater effect when they are on ortho and para position. So here nitrophenol will withdraw electrons more effectively when it is on para position, and not so when it is on meta position. Did you understand that? Is all of you?
Yes,
Look at
ma'am.
it carefully. And here in this case, again, the electron pumping effect of OCH3 will be more when it is on para position compared to when it is on meta position. Okay, so that is about the acidic nature. Now today we will look at more reactions of phenol, of alcohols and phenols due to the cleavage of which bond. So we understood that primary alcohols are more acidic than secondary, and they are more acidic than tertiary alcohols. I will show you that slide. Yeah, this slide. So this slide I specifically wrote here because in this one you can see this bond is most polar. So this bond breaks most easily, and compared to this one, and then compared to this one because of the plus I effect. The plus I effect is the greatest in tertiary, which decreases the polarity of O and H bond. So all those reactions where the O and H bond breaks, they will be fastest for primary and slowest for tertiary alcohols. So one such reaction was to compare the acidic nature. Now the next such reaction, second one, I will call it esterification reaction. Esterification reaction. Okay, esterification reaction. Now, what is esterification? You have learned neutralization reaction in inorganic chemistry. What is neutralization reaction? It is a reaction of acid and base to give you what? Salt and water, isn't it? It's a reaction of acid plus base. What is neutralization reaction? Neutralization reaction. What is neutralization reaction? It is a reaction of an acid plus a base, alkali, to give you salt plus water. Whenever you have this reaction, you call it a neutralization reaction. So if I take HCl and I react it with NaOH, what will I get? I will get NaCl plus H2O. This reaction is a neutralization reaction. Now, similarly, esterification reaction. What is esterification? It is acid, but this time it is organic acid. Organic acid plus alcohol. Reaction of an organic acid plus alcohol to give, as it gives ester plus water. It gives ester plus water. So organic acid plus alcohol gives ester plus water. You know what an ester is? Who will tell me what is an ester? You can call it
Ma'am,
an
ROR.
not ROR. ROR is
RCOR, ma'am.
RCOOR. It is ROR is ether. We are talking of ester. Okay. So ester is an organic salt which is formed by the combination of acid and an alcohol. You know, esters are the most the best, I should say, the best substances in organic chemistry, because all flavors, right, and fragrances, okay, they are due to esters. The fragrances, the sweet smell of rose is because of an ester present. So all flowers, the smell, typical smell of that flower is because of the ester present in those flowers. And flavors like pineapple flavor, vanilla flavor, all flavors, fruits have different flavors. They are also because of esters. So esters are the most beautiful substances of organic chemistry. Very, very nice. They are volatile substances. That is why you keep the rose flower in the room. The whole room smells of rose. Why? Because the ester present in that, it evaporates and it gives you that fragrance. So esters are how they are formed by a reaction of an acid and an alcohol. We are learning alcohol, reactions of alcohol. This is a special reaction when an acid and an alcohol combine to give an ester. Now let us take an example. So the acid, in such reactions, the first rule, in order to write the product easily, the first rule is you should write the acid first. So I will write an acid. So the acid that I'm going to write is ethanoic acid. Ethanoic acid plus ethanol. This is the reaction I want to see what will happen. So what is ethanoic acid? Let us write that. So CH3, C double bond O and OH. Okay, this is ethanoic acid, right? Now I want to react it with an alcohol. What is an alcohol? Alcohol is ethanol. What is ethanol? Now I will write ethanol in such a way that the OH of ethanol is on this side, right? This is ethanol, CH2, CH3. CH3, CH2OH, and this is CH3COOH, right? So this is. Now when I combine these two, in presence of concentrated H2SO4, right? What is the property of sulfuric acid? It can absorb moisture, water. It can take out water. Now, where is the water? Now, this reaction, in this reaction, here is OH and the H from the alcohol, right? So what have I removed? Water. So H2O. So I will write here H2O. And what remains now, let me write it carefully. You see how am I writing? CH3, C double bond O. And then you write the remaining compound O, CH2, CH3. Okay. So this compound that I got here, that is called an ester. Now let us name this ester. If you remember nomenclature from last year, can you name this ester? What is the name of this ester? Anybody? Ashwin should be able to answer because this does not require previous last 2 weeks, last 2 classes knowledge. What is the name of this ester? Anybody? Vaishnavi, can you tell me? Otherwise, I will have to teach in detail. Hariharan, do you know the name of the ester? Because you answered RCOOR, so I suppose you.
I don't know how to name it, like name it, ma'am.
Okay,
Esters.
okay. So we will learn. All of you have a problem in naming esters. Let us learn how to name them. So for naming the ester, what you have to do is first you find out, now you look at this carefully. In this formula, you can see one oxygen which is attached to alkyl group. What is this alkyl group with 2 carbon atoms? It is ethyl, right? And then you look at the remaining compound. This also has 2 carbon atoms, 1 and 2. So ethyl eth, and it always ends in O8. So this compound is called ethyl ethanoate. Esters are named like this. You can't take a continuous carbon chain. Why? Because there is oxygen in between. So divide the carbon chain into 2 parts. One carbon chain which is attached to oxygen. Take out that and write it first, ethyl. And then you write the remaining compound, eth, because there are 2 carbon atoms. Because it is an ester, it ends in O8. So ethyl ethanoate. So the product that I got here from ethanoic acid and ethanol is ethyl ethanoate. That is the ester. Okay, as a result of what reaction? Esterification reaction. Let us do a little practice. Now let me write again CH3O and OH, same acid I have taken. And this time I take methyl alcohol. Again with concentrated H2SO4. So water will be eliminated. So I will write H2O and write the remaining compound. So what will the remaining compound be? CH3, C double bond O, and OCH3. Now, what is the difference? This group here is CH3. What will I call it now? This will be called methyl. Rest of the compound is same, so it is ethanoate. Okay, methyl ethanoate. So the second half of the name comes from the acid. The first half of the name comes from the alcohol. So if the alcohol is ethanol, then it is ethyl. And if the acid is ethanoic acid, then ethyl ethanoate. This one is methyl ethanoate. Okay, we will practice because this is an important reaction. Now let me give you CH3, CH2, C double bond O and OH. Which acid is this? Can anyone name the acid? Come on, what happened? Which acid is this?
Propanoic acid.
Propanoic acid. Propanoic acid. And the alcohol is ethanol. Right? So when they react with concentrated H2SO4, you will get the water anyway, OH from the acid, H from the alcohol, right? So you will get H2O. And along with H2O, what will I get? Now learn carefully, write it carefully, all of you. CH3, CH2, C double bond O. So this part came from the acid. What will come from the alcohol? O, CH2, CH3. Now Vaishnavi, please try to tell me the name of this compound.
Yes, ma'am. Yes, ma'am. Ma'am, is it ethyl propanoate?
Very good. Ethyl propanoate. Okay. Hariharan, Hari Raghav, all of you understood?
Yes, ma'am.
Okay, very good. Now, that's the last one. Now, this time I am taking this acid plus a smallest alcohol and the smallest acid. Now, which acid is this? Methanoic acid. Only one carbon atom, so methanoic acid. Only one carbon atom, so this is methanol. Right? Now, if I do the same with concentrated H2SO4, what will I get? HC double bond O, and here I'll remove this. So H2O, but this is HC double bond O, and here OCH3. Hari Raghav, can you tell me the name of this ester? Hari Raghav, are you there? No, he's not there, I think. Hari Raghav is not there. And Sanjay can tell me. I didn't ask anything to Sanjay. Sanjay, tell me.
Can you repeat the question, ma'am?
This question, tell me what is the name of this compound that I have outlined? What is this group here? What is this one? Tell me. CH3 is known as what? What is the name of CH3?
Ethyl, ma'am. Ethyl.
Methyl, right? Methyl or methyl. Methyl, and what? How will I end the name? Which acid it is from? Methanoic acid. So what will be the name? Methyl methanoate.
Yes.
Understood? Did you understand, Sanjay?
Yes.
Okay, so methyl methanoate. So you can decide which ester you will get based on the name of the acid and the alcohol. To write the structure, it becomes easier if you write the name of the acid first, and then you write the name of the structure of the acid first, and then the alcohol. You can easily write the ester. Now, this question can be asked in two ways. One is few things about this reaction. This is a very slow reaction. It is a reversible reaction, right? So you have to keep on removing the ester as it is formed. And all these esters, they have a fruity smell. You identify the ester with the help of the fruity smell that they have. Now, the question in the exam, how it is asked is, how do you compare the rate of esterification of primary, secondary, and tertiary alcohols? Now you can see carefully here, which bond am I breaking? The same bond which I broke for checking the acidic nature, O and H bond. So all reactions in which O and H bond breaks, all such reactions, primary is faster than secondary and fastest is the tertiary alcohol. The slowest is the tertiary alcohol. So primary is fastest, and then secondary, and the slowest is the tertiary. So esterification is fastest in primary alcohols and slowest in tertiary alcohols. Why? Because the OH bond is most polar in primary and least polar in tertiary. Why? Due to the plus I effect. Okay, that is one part. The second part of the question, which is often asked, is you are given an ester and you have to tell which alcohol and which acid will give you this ester. So supposing I write here HC double bond O, OCH2, CH3, right? Can you tell me which alcohol and which acid will give me when I add water to them? What will happen? They will again change into the acid and alcohol. Sai Kalyan, which acid and which alcohol will give me this ester?
I will do and tell you, miss.
Yes, do it. So in the opposite direction, the reaction is called hydrolysis of esters, opposite, right? So this part, which I have marked out, that will give me the acid, and the other part, this will give me the alcohol. So if it is the alcohol, write H here and OH here, that will give you the product H, C double bond O and OH plus, now you write the alcohol CH3, CH2, OH, right? So this is what? Methanoic acid. And this is what? Ethanol. Got it? All of you?
Got it, ma'am.
Vaishnavi, yes. Vaishnavi, did you understand?
Yes, ma'am.
Okay. So this reaction is a very useful reaction. You just remember the reaction where alcohols are reacting with acids, and either side. If you know the acid and the alcohol, you should know the ester. If you know the ester, you should be able to say which acid and alcohol is given out by this reaction. Okay, so this was one part of the question. Now the same esterification reaction, similar to that, is another reaction. The third one, it is called acetylation reaction. Now, in this case, instead of taking the acid and the alcohol, we react the alcohol with acetyl chloride. So acetyl chloride is CH3, C double bond O and Cl. And what is my alcohol? HOCH2CH. This is my alcohol. Always write the acid or its derivative first. And now this time, what will I do? What can I remove? I can remove HCl. Instead of water, what do I remove? HCl. And then what remains? CH3, C double bond O and OCH2CH. So here also I get the ester. The difference is that along with ester, I will get HCl. Okay. So this reaction, it is known as acetylation reaction because instead of a H in the alcohol, we introduce a acetyl group. What is the acetyl group? Acetyl word comes from acetic acid. What is acetic acid? CH3C double bond O, right? We do acetylation of benzene. Similar in, you remove H from the benzene and introduce CH3CO group. This is the acetyl group, right? So acetylation reaction is similar to esterification. Why? Because here also we get an ester, but we don't call it esterification because we don't get byproduct as water. Esterification is basically one where we get a byproduct as water. Now, when we are using phenol, supposing we have a compound, now I'll make the, let's see whether you understand my camera. Okay, so now I have this compound, right? This is the OH group, right? And this is a COOH group. This compound is known as salicylic acid, right? Now, if this compound reacts with CH3COCl, right? Where will the reaction take place? Instead of H, here, this is the alcoholic group. Now, you should be able to visualize what happened. Now, to simplify this reaction, I will write another compound here, CH3OH, supposing it was. And it was reacting with CH3COCl. Okay. I have showed you in which way. I have showed you writing acetyl chloride first. Now, if acetyl chloride is written second, how will I write the product? Cl from here and H from here will go. HCl is removed. So what remains? CH3O. And then you invert and write the remaining compound OCOCH3. Okay, OCOCH3, because in CH3COCl, it is like this, right? So carbon forms a bond. So instead of H, what do you put? COCH3. So I can do that here in place of alcohol. So what will I get? COH group will remain as it is. But instead of OH, what will I write? OCOCH3. What will I call this one? Acetyl salicylic acid. And you know what this acetyl salicylic acid is? This is a very important medicine which you would have heard. It is sold by the name of aspirin. Have you heard of aspirin? Any one of you? Have
Yes,
you
ma'am.
heard of? Yes, Ecosprin, Disprin, all those aspirins. Why do you use them? For a headache, isn't it? Many times you use Disprin for a headache. This is obtained by acetylation reaction of salicylic acid. So this reaction is acetylation in case of phenols. Okay, so phenols also can undergo acetylation reaction. What will be the byproduct? HCl. Okay, so these three reactions that we learned, esterification, acetylation, and also a reaction of acidic nature of alcohols, all these reactions will be very fast for primary and then for secondary and the slowest for tertiary alcohols. Okay, now we will do next few reactions, next set of reactions. The next set of reactions, the special reactions of alcohols, the second type, this is type 2 reactions. Now, these are those reactions where, you know, in an alcohol, if you see, this is again, I will write a primary alcohol. And now another one, a secondary alcohol. And a tertiary alcohol. Now you can see a small observation. This time I have shown which bond have I shown very long? This bond is very long, right? This bond. Right, so we are looking at those reactions where carbon-oxygen bond breaks. In the previous set, what were we looking at? The polarity of O and H bond. Now this time we are looking at the polarity of carbon and oxygen bond, right? Now in which direction will oxygen pull electrons from carbon? Oxygen is electronegative, so it is pulling electrons in this direction. Here also oxygen is pulling in this direction, here also pulling in this direction, right? And what is the effect of CH3? Also in the same direction, plus side. Here 2 CH3, also in the same direction. And here 3 CH3, all in the same direction, right? So here, what is the plus I effect? What is the plus I effect doing? It is increasing the polarity of O and H bond, right? So here, the tertiary alcohols will show the fastest reaction and primary will show the slowest reaction. Why? Because this C and O bond will break very easily for tertiary alcohols, because this is the most polar because of the plus I effect of 3 CH3 groups. So now you see the plus I effect makes O and H bond, it affects differently, and C and O bond, it affects differently. So it increases the polarity of C and O bonds, and it decreases the polarity of O and H. Okay, so did you understand? So see carefully. So here the primary alcohols are the slowest, and then secondary, and then tertiary. Now look at a few reactions of this type. Now the first reaction of this type is reaction with halogen acids. Halogen acids. What are halogen acids? HCl, HBr, and HI. Now we will take an example of HCl. So let us write a reaction. We'll show the fastest one first. So I will take a tertiary alcohol and I will write a reaction with HCl. Okay. Now HCl that we take here is concentrated, and we take a catalyst here, zinc chloride. Now when we take this combination of concentrated HCl and zinc chloride, what do you think will happen? A substitution reaction where OH will combine with H of the HCl and form what? Water. And instead of OH, what will come? Cl. So this OH bond is breaking now. So CH3, and OH. Cl is replaced by OH with the help of. Now, Cl, I should write, sorry. Here it should be. OH is replaced by Cl. Right? Now this reaction happens instantly. At room temperature, this reaction happens instantly. Now, how will you know that the reaction has happened instantly? As soon as I add HCl and zinc chloride mixture to a tertiary alcohol, the solution will become cloudy. So cloudiness appears immediately. Why does it become cloudy? Because alkyl halides are insoluble in water. So as soon as I add HCl to the alcohol, it becomes cloudy if it is a tertiary alcohol. Okay. Now the second reaction here. So if I take a secondary alcohol instead of a tertiary alcohol, same reaction will take place. OH will be replaced by Cl, so I will get CH3CH, CH3Cl, and H2, right, in presence of zinc chloride. This reaction will also happen fast, but after 5 minutes. It doesn't happen instantly. It becomes cloudy, but it becomes cloudy after 5 minutes. Now, if I take a primary alcohol, CH3CH2OH, and I react it with HCl, in presence of zinc chloride, there is no reaction at room temperature. I will have to heat it, and only on heating, I will get CH3CH2Cl plus H2. So cloudiness will appear only on heating. Okay, no cloudiness at room temperature, right? So what can you say? Tertiary reacted faster than secondary, and the slowest was primary. Now this reaction is used for distinguishing between primary, secondary, and tertiary alcohol. If an alcohol is primary, tertiary, or secondary, there are 3 alcohols given to you, and you have to identify which one. Then you can use HCl and zinc chloride to distinguish between primary, secondary, and tertiary alcohol. Tertiary will give immediate cloudiness, secondary will give cloudiness after 5 minutes, and primary will give cloudiness only on heating. Now this combination of concentrated HCl plus zinc chloride, it is known as Lucas reagent. Lucas reagent, and that is why this test here, it is known as Lucas test, to distinguish between primary, secondary, and tertiary alcohols. So all those reactions where substitution is going to take place in such a way where OH is going to be replaced by something else, in such reactions, tertiary alcohols will always be fastest, and then secondary, and then primary alcohol. So we can look at one or two more reactions and see how these reactions take place. So similarly, you can see the reaction of alcohols with PCl5, PCl3, SOCl2. I am not going to write those reactions again because you have seen those reactions in preparation of alkyl halides. Okay, so I will just write a general reaction ROH in the presence of what? PCl5 or PCl3 or SOCl2. What will happen? OH will be replaced by what? RCl. Okay, so this is also a reaction where OH is being replaced by Cl. So these were the important reactions where the O and H bond breaks. Now the type 3 reactions. So among type 3, the first reaction is dehydration of alcohols. Dehydration of alcohols. Right? Now this dehydration of alcohols is also something that you have learned in class 11. In class 11, you have learned preparation of alkenes by dehydration reaction. Okay, so let me write an alcohol here and see how a dehydration will take place. So this is the expanded form of ethanol. Okay, expanded form of ethanol. Now, if I do dehydration, means I have to remove what? Water. So for removing water, what will I remove? One H and a OH. So this is my water. If I remove H and OH from adjacent carbon atoms, a double bond will be formed here. So what will I get? CH, double bond CH plus H2O, right? How will I bring about dehydration? With concentrated H2SO4 at 170 degrees Celsius. At 170 degrees Celsius. So this is called a dehydration reaction. Okay, let us see how we can bring about dehydration reaction. Here again, remember, tertiary alcohols get dehydrated most easily, and then secondary and the primary alcohols require higher temperature for dehydration. Now let us see what are the different alcohols and how we write a dehydration reaction. Now supposing I had CH3, CHOH, CH3, right? What alcohol is this? This is 2-propanol. Who else has gone now? Hari Raghav also left. Ashwin also left. No message in chat. So Vaishnavi, Ashwin, Vaishnavi, Sanjay, Hariharan, Sai Kalyan, are you able to understand? Because I don't see you all, you don't say yes or no, nothing. I don't know whether you are there.
Understood, ma'am.
Okay, all of you understand. Okay.
And
Okay, very good. Now you see, I want to remove the alcohol, water. Okay, so minus H2O I want to do with concentrated H2SO4 at what temperature? 170 degrees Celsius. Right? Now, what is the product that I will get? Can you tell me what product I will get here? OH will go from here. and H will go from the adjacent carbon atom. So I can remove either from the left or from the right. Both carbons are same. So I will get CH3, CH, double bond CH. So I can remove H from here and OH from here. So these two carbons are affected. So between these two carbons, I put a double bond. So I get what? Propanol 2 will give me propene. Now let me take one more CH3, CH, OH and CH2, CH. This time it is 2-butanol. Right? I can tell you about one more dehydrating agent, and that is phosphoric acid, H3PO4. Okay, almost 80% concentration of H3PO4. That also acts as a dehydrating agent. So again, I will remove water, H2O. Where is my OH? Here, no problem. But now there is a question, where will the H go from? So here we follow a Sedzef's rule. What is a Sedzef's rule? Sedzef's rule says that the OH, when in case of dehydration, the Sedzef's rule follows all elimination reactions. So when it is dehydrohalogenation or it is dehydration, it follows the same rule. And nobody asks you what a Sedzef's rule is. You can always remember poor becomes poorer. I have told you while doing dehydrohalogenation of alkyl halides. So poor becomes poorer. That means hydrogen will be removed from that carbon which has less number of hydrogen atoms. So one carbon is here, this is 2, this is 3. So from 2, I have already removed OH. Now where will I remove Vaishnavi? Will I remove hydrogen from 1 or will I remove it from 3?
Ma'am, is it from 1, ma'am?
Which is poor? 1 or 3?
Poor, ma'am, but more number of alkyl group is attached to the third one.
No. Just look at the carbon. So one carbon which is directly attached to 2. So which is that? Third one. Third one is poor. Why? Because it has 2 hydrogens. And this one is...
See only that adjacent carbon's
yes,
hydrogen.
only the adjacent carbon. Okay.
Oh.
So the product will be CH3, CH double bond, CH, CH. Okay. So 2-butene will be the major product. 2-butene will be the major product. Okay. Not 1-butene. So hydrogen will be removed from that carbon, that adjacent carbon, which has less number of hydrogen atoms. So you will get 2-butene. Okay. Now let us practice this. This is also important. So supposing I have a tertiary alcohol. No, let me draw one more, this one, CH, CH2OH. Okay, what will I get on reaction with concentrated H2SO4 at 170? What will be the product? So OH will go from here. All right. Now where will the H go from? It is easy here. Where will the H go from? Sai Kalyan? This is 1, this is 2, this is 3. Where will the H go from?
Second carbon, miss.
Yes, second carbon. So what will I get? 2-methyl 1-propene, right? 2-methyl propene. Okay, so OH from here and H from here. So this is a dehydration reaction of alcohols. And as I told you, dehydration is fastest for primary and tertiary and slowest for primary alcohol. So here also T is greater than S is greater than P. Okay, so that is how the dehydration reaction takes place. Okay, you also have to learn in your syllabus, there is a mechanism of dehydration that you have to learn. How does dehydration take place? Okay, so I will just explain the mechanism. For few reactions, you have to learn mechanism. Dehydration is one of them. Now this reaction, which are the reactants taking part in the reaction? One is the alcohol and one is the acid, concentrated sulfuric acid. So concentrated H2SO4, you know, it will ionize and give you what? It will give H plus HSO4 minus. H plus HSO4 minus. आज तो जाना चाहिए तुम्हें. All right. So this is what you get. Now this, let me write the alcohol. So my alcohol is, say, ethanol. So this is ethanol. O and H. Right? So this alcohol has this oxygen with lone pair of electrons. So this oxygen reacts with H plus. And what does H plus do? It goes and attaches to this oxygen. Why it is go? This is a proton, no electrons. So it goes and forms a coordinate bond with this oxygen. So what will you get? H, C, H, C here, CH2, and here O and H, and a new H will come and form a bond. Right? Now this oxygen has loaned an electron to hydrogen, then only a bond is formed. So this oxygen will become positive. Right? And oxygen with a positive charge is not stable at all. So this bond will break here. And what will happen? You will get CH3, this part, CH2, positive. This bond has broken. So I will get plus H2. So what is the CH3, CH2? What did I get? CH3 and CH2 plus. This is called a carbocation. A carbocation is formed. See, I told you about carbocations when we did SN1 and SN2. So same way here, a carbocation is formed. How is a carbocation forming? By the protonation of alcohol. So what is the first step of the reaction? First step of the reaction, it is known as protonation of the alcohol. Protonation of alcohol. So first protonation of alcohol happens, and what is the second step? Elimination of water. Okay, so to write the mechanism, first step is what? Protonation of the alcohol. O forms a bond with H. And then this bond breaks here and water is eliminated. So that is elimination of water. Now what happens next? Let me show it in the next slide. So what happens next is you are left with CH3, CH2, and plus carbocation, right? Now what happens is this carbocation has a positive charge. Now it is not stable. It has to become stable by getting rid of this positive charge. So in the first step, what did we do? Addition of a proton, protonation. Now this step, it will be elimination of a proton. Elimination of a proton. How will the elimination take place? The HSO4 minus that was formed earlier, right, from sulfuric acid, it comes here and it takes the H as H plus, right? So it again becomes H2SO4. Then what happens? Your H goes as H plus, so this carbon then becomes negative. This is H, and this carbon was positive already, H and H. right? So this negative and positive will form a bond. So what will you get? CH2 double bond CH2, right? So this is a mechanism of elimination reaction or dehydration reaction. So dehydration reaction is what type of reaction? It is an elimination reaction. When do we have an elimination reaction? Elimination reaction happens when a saturated compound forms an unsaturated product. So alcohol is saturated. The product that you have got is an alkene, which is unsaturated. So what type of reaction am I doing? Elimination reaction. And this elimination reaction happens in 3 steps, right? First step is protonation. First step is called protonation. Protonation. Second step is elimination of water, elimination of H2O. And the third step is elimination of a proton. Okay. So when 2 eliminations happen in a product, 2 things are removed, then always a double bond is created. Okay, a bond is created. When you remove 2 things, you remove, then a double bond is created. So these are the steps for elimination. Okay, I hope all of you have understood this part. Now we'll do the most important part of our alcohols, and that is oxidation of alcohols. Oxidation of alcohols. We are doing alcohols right now. Dehydration of phenols, we don't talk about. Phenols don't get dehydrated. Only alcohols get dehydrated, and tertiary will get dehydrated fastest. Now the next reaction, which is very, very important, 5-star reaction. This is oxidation of alcohols. Now, how do we do oxidation of alcohols? Now you see, what is the definition of alcohol oxidation? Definition of oxidation is either removal of hydrogen or addition of oxygen, isn't it? You have learned last year in redox. What is reduction? Reduction is addition of hydrogen. What is oxidation? Removal of hydrogen or addition of oxygen. So let us take an alcohol and try to remove hydrogen. So this is my, again, ethanol. We always try simple examples. So, right, this is my alcohol, O and H. I have deliberately written it like this, CH3, CH2, OH. Which alcohol is this? This is ethanol. Now what I am doing is, I am going to remove hydrogen from here. How? These 2 hydrogens. One which is attached to oxygen and one which is attached to adjacent carbon. And whenever I remove 2 things, what do? I create a double bond. So what will be the compound that I will get? CH3, no change here. Here I will get CH and double bond O. What is this compound? CH3, CH double bond O, right? So what did I do? I removed a H from here and a H from here, right? And since I removed this reaction is what? Oxidation reaction. You write oxygen in the square bracket. That means some oxygen is being, some reagent is supplying this oxygen, which is taking out 2 hydrogens and minus H2O. In this minus H2O, oxygen is being provided and that oxygen is pulling out 2 hydrogens. So this was what? Ethanol. And this is what? Ethanal. Right? So this is an acid, and on oxidation, what is it giving me? An aldehyde. Which type of acid this is? Oh, sorry, this is, I'm sorry, this is an alcohol. This is an alcohol, and on oxidation, it is giving me an aldehyde. This is a primary alcohol. So primary alcohol on oxidation, that means ethanol on oxidation has given me ethanal, and that is an aldehyde. So I can say alcohols on oxidation, they give aldehyde. But the reaction doesn't stop here. The reaction goes on further. If I do oxidation now, then the oxidation is by addition of hydrogen. So if I do oxidation here, now how will I add hydrogen or oxygen now? This is CH3. This is C double bond O. This oxygen goes and attaches here in between hydrogen and carbon. It will become OH. So how do what did I get? CH3, COOH. Right? What is this? Ethanoic acid. Ethanoic acid. So alcohol on oxidation can give me aldehyde, and aldehyde on oxidation will give me carboxylic acid. And what is more interesting is this is also H, this is also H, and this is also H. So primary alcohols on oxidation, they give aldehydes and acids with same number of carbon atoms. With same number of carbon atoms. Now let us use this for other alcohols. So supposing I have CH3OH. Can I write the aldehyde? Yes, OH from here and H from here. So if I remove one H, what will CH3 become? CH2, double bond O. So this is methanol, and this is methanal, aldehyde, methanal. By doing what? Oxidation. And if I do oxidation further, I will get what? Methanoic acid. So an acid with one carbon atom, how will I write? COOH, and here it is H. HCOOH. Okay. So methanoic acid. Now let me write another one, CH3, CH2, CH2OH. So this is also primary alcohol. So on oxidation, what will it give? A primary, an aldehyde. Which aldehyde? CH3, CH2, and H from here and H from here. What will be left? CH. And now how will I make it into an acid? CH3, CH2, COO. Right? So you will get an aldehyde and an acid with same number of carbon atoms. Okay. So this was what? Propanol. One propanol. And this was propanal. And what was this? Propanoic acid. Right? So if I write a general reaction, how can I write? RCH2OH. On oxidation will give me RCHO. So CH2OH changes into CHO. And then on further oxidation, RCHO will change into RCOOH. So what am I doing? CH2OH changes to CHO, and CHO changes to COOH as a result of what reaction? Oxidation reaction. So alcohols, primary alcohols on oxidation will give aldehydes which readily get oxidized to acids. Okay. Now let us see the oxidizing agent. The oxidizing agent which can bring about this reaction. I didn't talk of the reagent as yet. So oxidizing agents. So the strong oxidizing agent which can convert alcohols to aldehydes and aldehydes to acids. First one is K2Cr2O7 plus dilute H2SO4. So this is a very strong oxidizing agent. You will never be able to, it is difficult to isolate the aldehyde because alcohol will change to aldehyde and quickly, very quickly, aldehyde changes to acid. So basically, if I take ethanol, CH3CH2OH, and I do oxidation in presence of K2Cr2O7 and H2SO4, my main product will be CH3COOH because the aldehyde which will form will continue to get oxidized to give me an acid. However, if I use another oxidizing agent like PCC, what is PCC? PCC is pyridinium chlorochromate. Okay, PCC. So if I use an oxidizing agent like PCC, then what will I get? Then I will get an aldehyde only. So if I take CH3CH2OH and I do oxidation with PCC, then my major product is CH3CHO and aldehyde. So PCC can convert the alcohol into an aldehyde. PCC prevents further oxidation of aldehyde into an acid. So if I want only an aldehyde, then I should use PCC. If I want to get an acid, then I should use K2Cr2O7 and H2SO4. Right? Did you understand the oxidation reaction of primary alcohols? Now let us take the secondary alcohols. So oxidation of secondary alcohols. Now secondary alcohols, they do not get oxidized easily. So, but if they get oxidized, so supposing I write a secondary alcohol, CH3, right? This is a secondary alcohol, right? So what will I do? I will, in order to do oxidation of the secondary alcohol, what will I do? I will take the OH from here and H from the adjacent carbon. H from here and H from the adjacent carbon. So oxidation. What will I be left with? CH3, C double bond O and CH3. So this is 2-propanol. And on oxidation, it gives me propanone. So secondary alcohols on oxidation, what do they give? They give ketones. They don't give aldehyde, but they give ketones. I hope you know to distinguish between an aldehyde and a ketone. Yesterday, while doing Grignard reagent, I pointed it out. When the C double bond O is attached to 2 alkyl groups, then it is a ketone. So secondary alcohols will always give ketones, and ketones don't get oxidized further. The secondary alcohol and ketone will have same number of carbon atoms, but ketones do not get oxidized further. So the major product will be only ketones. And here again, we can use either K2Cr2O7 and dilute H2SO4, or we can even use PCC. Even if you use this reagent, you will only get a ketone. But if I want to if I heat it along with the first reagent, that is potassium dichromate and dilute H2SO4, then the ketone may break down and give you acids, right? On heating with Cr2, K2, Cr2O7 and H2SO4. If I do this, then ketone will give me acids, but these acids will have less number of carbon atoms as compared to the alcohol. So we will learn this part later when we do aldehydes and ketones, oxidation there. Right now, you just learn secondary alcohols, they give you ketones, and primary alcohols, they give aldehydes and acids with same number of carbon atoms. So that is oxidation of secondary alcohol. Tertiary alcohols do not get oxidized easily. If you want to oxidize them, they undergo actually dehydration rather than oxidation. So you can't write any clear product of oxidation of secondary alcohols. Now you have learned two contrasting reactions, one in the forward direction and one in the backward direction. Forward direction where an alcohol gets oxidized into aldehyde and then into acid, and reduction where an acid gets reduced into an aldehyde and aldehyde into an alcohol. So I want to show you both in order and write both of them for you to understand. So CH3, CH2, OH, right? This is first one. And the second one is CH3, CHO. And the third one is CH3, COOH. Okay, ethanol, ethanal, and ethanoic acid, or ethyl alcohol. This is called acetaldehyde. This is called acetic acid. Now, if I want to convert it into an alcohol, an acid, what will I take? K2Cr2O7 and H plus will give me the acid. If I want to make only the aldehyde, then what will I do? I will take PCC. Now backwards. If from the acid I want to make the alcohol direct, then lithium aluminium hydride reduction. And if from the aldehyde I want to make the alcohol, then I can also use NaBH4, right? Sodium borohydride can reduce the aldehyde into alcohol. It cannot reduce the acid into the alcohol. So these are four reagents which are very, very specific. So for oxidation, we use potassium dichromate and H plus and PCC, and for reduction, we use NaBH4 and LiAlH4. Now this lithium aluminum hydride is a strong reducing agent, and potassium dichromate and dilute acid is a strong oxidizing agent. Just remember that, then this will be very useful in conversion. So remember all these reactions. Okay. Now we have to do one more reaction, the last one for today, and that is dehydrogenation. Dehydrogenation can also be called a reaction like oxidation because we are removing hydrogen. But here the reagent that we use is copper at 573 Kelvin. So copper at 573 Kelvin can act as a reagent which brings about dehydrogenation. So if I take a primary alcohol, CH3, CH2OH, and I react it with copper at 573 Kelvin, then dehydrogenation will take place and I will get aldehyde. Right? And if I take a secondary alcohol, CH, OH, and CH3, and I take copper at 573, then H and H from here will be removed. So I'll get CH3, C double bond O, CH. So this is an aldehyde and this is a ketone. So primary alcohols on dehydrogenation give aldehydes, and secondary alcohols on dehydrogenation, they give ketones. Okay. So this is like the first step. Now here I can do this also with which oxidizing agent? PCC, right? I can do this also with another reagent, that is PCC. So PCC also acts the same way. Why does copper bring only dehydrogenation? Because the hydrogen which is produced in the reaction, it prevents further oxidation of the aldehyde or the ketone. So you get only dehydrogenated products. Okay, so that is now done. Now we will do a few simple conversions before I take the reactions of phenols, because then that is a little difficult, so it needs another class. So we will do a few conversions today, just to wind up the lesson, so that these conversion reactions will help you to do revise whatever we have done in alcohol. So first thing I want to do is I want to convert methanol into ethanol, CH3, CH2OH. Okay, it is stepping up reaction. I want to convert methanol into ethanol. Now, how can I do this? So for the first one, I will give you a hint. You are increasing a number of carbon atoms. So whenever you increase the number of carbon atoms, you have to remember what is it that you need to do. You can use Grignard reagent, because Grignard reagent always increases. And you are going to make a primary alcohol. So primary alcohol, what do you need? You need formaldehyde. So what can I do here? First, I can do copper at 573 Kelvin. So what will copper at 573 Kelvin give me? Formaldehyde or methanol. And methanol with Grignard reagent, CH3MgBr, in presence of H2O and H+, I can immediately get ethanol. So methanol can be changed into ethanol, or methyl alcohol can be changed into ethyl alcohol by this. Now the same method I can do for converting ethanol to 2-propanol. Can I do it? So let us try CH3CH2OH with copper at 573 Kelvin. What will I get? I will get an aldehyde, CH3CHO, right? And CH3CHO plus CH3MgBr in presence of H2O and H+. What will it give me? 2-propanol, because all aldehydes other than formaldehyde, they give us secondary alcohols. So methyl magnesium bromide will give me 2-propanol. So by using Grignard reagent, you can do stepping up reaction. Stepping up means getting products which have more carbon atoms than the reactants. Now the next one which I would like you to think about is you do CH3, CH2, CH2OH, 1-propanol. I want you to convert it into 2-propanol. Now tell me, anyone who can give me an answer for this. This is the last question for the day. Who can give me the answer? Vaishnavi, can you think of something?
Hmm.
They are both linked with propene. So what will I do first? I'll do dehydration. Right? Dehydration means remove minus H2O. How? With concentrated H2SO4 at 170 degrees Celsius. So water will be eliminated, I'll get propane. And now I can again add H2O, add water, right? Addition of water, what will I get? Propene will give me. And when I add water, what type of addition? Markovnikov addition. So OH goes to that carbon which has less number of hydrogen atoms. So you get OH here, and you will get 1-propanol will change into 2-propanol. Okay?
Yes, ma'am.
Now all of you, please switch on your cameras. Vaishnavi, did you understand everything? It's,
Yes, ma'am.
do you feel that 1.5 hours is too much? We should take only 1 hour, because towards the end, I think it becomes tiring. So are you able to understand the whole 1.5 hour class, or you after 1 hour you get a little tired? Then I want to request them to reduce the duration. Right? Chemistry is very exhausting. I don't know how you feel in physics, but it becomes a little exhausting. Hariharan, what about you? Did you understand everything? I tried to be
Yes,
as
ma'am.
slow as. Yes, very good. Sai Kalyan, everything you understood?
Yes,
Very
miss.
good. And one more person is there. One more person is there. Who is the next person whom I don't see? Participants. Sanjay, are you there, Sanjay?
Yes, ma'am.
Okay. So see you all. Tomorrow also we have a class. So tomorrow we'll finish phenols. So, but then after that you have no class for 1 week. So you can slowly absorb whatever you have learned. You can revise and absorb. 1 more week you will have no class. Next class will be after tomorrow. Next class maybe on the 1st of July only. Okay. So
Okay, ma'am.
all the best to all of you. Please read from the textbook and ask whatever you have not understood. Okay, bye.
Thank you, ma'am.
Thank you, ma'am.
Bye.
Thank you, Miss Douglas.